Hi class, this is a tutorial video about how to prove triangles are congruent, and we're going to do this a couple different ways. The first way is using the definition of congruent triangles, which we looked at before. Triangles are congruent if all of their corresponding sides are congruent and all of their corresponding angles. So corresponding just means they are in matching locations. So in this picture here, Z and A are corresponding, they're congruent. X and Q are corresponding. You can think of this triangle as kind of like flipped over. They're corresponding, they're congruent, they have the same congruency markings. And J and F are congruent, they have the same congruency markings. Same with the sides. This segment correspond and are congruent. My longer sides here are corresponding, they're congruent, and the bottom bases are also congruent. And when you say that they're congruent, you have to say them in the matching order. So if I name this one AQF, I want to list it in the same corresponding order with the second triangle. So Z corresponds to A, and then X, so ZXJ. So we want to go in the same order when I write my congruency statement. Okay? We are looking at a few things that we've already seen before down here, but kind of some helpful review that we're going to continue using. But reflexive property is saying something is equal to itself. We see this in geometry a lot when we have a shared side, so like overlapping triangles. So in this scenario, PQ is congruent to QP because it's shared in both triangles. And the reason the order is switched here is because, again, I'm saying it in the same order. So APQ, do you see that angle? I would go A, then P, then Q. To name this one, I would go B, then Q, then P. So naming that side for the left triangle would be PQ, but for the right triangle to correspond would have to be QP. But since it's the same thing, it's congruent to itself, and that's the reflexive property. All right, vertical angles. Okay, L corresponds to O, M to P, and N to N. So again, I can name these angles, vertical angles, but I want to name them in the same corresponding order. So angle LNM, and since L corresponds to O, I want to start with O. O and P, they're congruent by the vertical angles theorem. Okay, and we'll see that a lot with triangles, kind of they're connected at the tip there. And a reminder of some of our special angle pairs. Linear pairs corresponding alternate interior, alternate exterior, same side interior, and vertical. We will see those occasionally pop up in our triangles. Okay, so let's do a few examples. So we've got a polygon, LMNP, and EFGH, and I'm told that they are congruent. Identify all pairs of congruent sides and angles. So these are ones that have to correspond. So L, since it's listed first, corresponds to E. So angle L has to be congruent to angle E. And we can just kind of keep going down the line. M corresponds to F, N to G, P to H. So I'll let you guys finish that one. I'm not going to keep going. But we can do the same thing with the sides. So LM would make up one side, EF would make another, and those correspond to each other. So I could say that, start this way here. LM has to be congruent to EF. And then we can work our way down. So instead of LM, now I can do MN. Is congruent to a second, third would be FG. And again, you can keep working your way down. MN, NP, PL, until we get all of them. So you should have 4 sets of angles and 4 sets of sides that are congruent. Okay, this one. Write a congruency statement. So they're telling me that they are congruent here, and I want to write the proper statement. So triangle, just use that symbol for triangle, and let's just name this first one. And there are lots of ways to name it. I could do ABC, BCA, CAB. Let's do CAB. Now I'm going to say it's congruent to this triangle. Now the important thing is I have to name it in the same order I named this one. So since I started with C, which is my right angle, I have to start with F, which is my right angle here. So triangle, F, and then I went to A, so I'd have to go to D, and then back up to E, so that each of these letters line up as corresponding parts. Okay, using the definition here, all right, I'm given that these two triangles are congruent, find the value of x. So when I have congruent triangles, all their corresponding parts are congruent. So these triangles are exactly the same, but this one has kind of been flipped upside down. So if I were to flip it right side up, this side I could see matches up with this side. Okay, so I can set 2x minus 2 equal to 6 because they have to be exactly the same. Add 2 to both sides, divide by 2 to get x equals 4. And that's part A. Part B is to find the measure of angle E. So again, this is flipped upside down, but if I were to flip it up, angle E would be up here, and it corresponds with angle B. So it also has to be congruent to angle B, and B is 53 degrees, so angle E is 53 degrees. Okay, number 3. We are given that AD bisects BE, BE bisects AD, AB is congruent to DE, and angle A is congruent to D. So we got lots of givens, and we're trying to prove that these triangles are congruent. So remember, every single corresponding part, sides and angles, has to be congruent in order for the triangles to be congruent. So I'm just going to do my usual where I circle all my givens, draw an arrow here, say given. But I'm going to add some markings to my drawing so I know about those. Well, actually these are taken care of. AB is congruent to D, I've already got the markings. Angle A is congruent to angle D. So let's talk about this bisect piece. What does that mean exactly? Well, AD is bisecting B, meaning it's cutting BE into 2 equal parts. So since I added that to my picture, I'm going to add that to my proof as well, that BC, and since B corresponds to E, I'm going to name E first on this one, is congruent to EC. And the reason I know that is because of that word bisect. That's what it means. So the definition of bisect here. And I have the same thing happening the other way, that BE is cutting AD in half. So I'm going to use 3 tick marks on this one. So I know that AC is congruent to DC, again, from that definition of bisect. Okay, so we've got all pairs of sides are equals. Now I need all the angles to be equal. Okay, so we have a pair of vertical angles happening right here around C. Let's go ahead and name those and know that those are congruent. So I'm going to say ACB. And since I named A first, D matches up with A, so I do DCE on this next one. And that's because they are vertical angles. Okay, so I'm almost there. I just need this third pair of angles. Well, remember from 4.2, if I have 2 pairs of angles that are congruent, that automatically makes the third one congruent. So I can say that angle B is congruent to angle E by the third angles theorem. Okay, well, and I'm going to add those last little congruency markings there. And so I've got all 6 pieces are congruent, so I can say that ABC, that triangle, is congruent to triangle DEC and matching exactly what I'm trying to prove by the definition of congruent triangles, which says if all their pieces are congruent, then the triangles are congruent. Okay, we've got one last one here. And we're going to use this diagram to prove that triangle ADR is congruent to CBR. So that's kind of this left triangle. I'm going to actually maybe even shade that in just a little bit so I can see those. Okay, and we've got lots of givens again, and one that I'm going to add that's not marked right here, actually none of them are marked. AD is congruent to BC. And they're parallel, so I'm going to add those parallel arrows on there as well. Okay, and we've got some more bisecting happening. So I'm going to add these to my proof here and leave all this in here. Okay, so let's talk about what that bisect gives us in this picture. So DB is bisecting AC, so we get another pair here. And we've got bisecting happening the other way as well. So very similar to number 3. That we get a couple more pairs of congruent sides. So AR was one of those, being congruent to CR from that word bisect. And we've got DR congruent to BR for that same exact reason. Okay, so now I've got another pair of vertical angles I can see here. I've got around R, so angle DRA is congruent to, and D and B are corresponding, so I'm going to do angle BRC. Oh, sorry, that should be an R. RC by the vertical angles theorem. So this is looking a lot like the other proof we did, but I don't have an angle already given to me as congruent. But I do know something about when I have parallel lines. So if I think about this parallel lines here, then these diagonals are kind of acting like transversals, right? So C and A are actually alternate interior angles if this is my transversal and these are my parallel lines. So I can say that angle A is congruent to angle C by the alternate interior angles theorem. And then we can use the third angles theorem again for B and D, or we could say alternate interior angles for this one as well, because this is my transversal with my parallel lines. So either way, we can use the third angles theorem or alternate interior angles theorem for this one to say that angle B is congruent to angle D. And I'm going to say third angles for this one. Okay, and we've shown all 6 parts are congruent, so the triangles are congruent. Triangle ADR is congruent to triangle CBR by the definition of congruent triangles. Alright guys, that's the last one. Thanks for watching.